I should Alt-T.
Okay, so what we're going to do is we're going to talk about solving rational equations and inequalities. I expect that this is a review from our experience in our algebra 2. All right, and here's the first example I'm going to do. So let's say we have x plus 5 equals 14 over x. Now what makes this a rational equation is that I have a rational function on the right, which means I have basically an x in the denominator or something with an x in it in the denominator. So typically what I do is find a common denominator, and in this case that would be x, very simply, right? And before we even start, can x not equal something? Right, so we already know before we start that x can't be 0. So if we get 0 at the end, then we know that's extraneous. So with rational equations, we have to check for extraneous solutions if we have an x in the denominator. Okay, so common denominator is definitely x. So I'm going to multiply the left side, by x over x, which gives me x squared plus 5x all over x equals 14 over x. Now, I have two expressions, the one on the left and the one on the right, and they're equal. And their denominator is already equal. So what has to be true about the numerators? They have to be equal. So I'm going to just think about this equality here and solve it. So this is going to be x squared plus 5x. And I'm going to subtract the 14 over already, equals 0. And lucky for us, this factor, so this is x and 7 and 2 and plus and negative. And so what are our zeros here? We get x equals 2 and negative 7, which are not equal to 0. So both of these work. Yes?
Could you just multiply x by both sides?
Okay. You could do that, but in calculus, I really want you to be able to keep the denominator, because in calculus, critical points occur when the numerator is 0 and the denominator is equal to 0. So it's really important that we keep that denominator. Okay? Yes, I know it's annoying. All right, so let's say I take this very equation here, and I make this an equation and make it an inequality. Well, that's a little bit weird. So let's say we have x plus 5. This will be part B of this example. And let's say we make that as less than or equal to 14 over x. Now my strategy on this is a little bit different. To solve these inequalities, I first set them equal to 0. Or, I put a 0 on one side. So I'm going to move the 14 over x to the left side here. I'm going to say x plus 5 minus 14 over x is less than or equal to 0. Finding a common denominator, again, we already know that it's going to be x squared plus 5x minus 14 all over x is less than or equal to 0. Now, when I do these inequalities, what I do is I do a sign chart. I don't hear any groaning, so that's a good sign. And in order to do a sign chart, I need to know what the zeros are and where things are undefined. And we already know that this was x plus 2 x minus 7. I'm going backwards, right? Sorry, backwards. So we're going to use a sign chart. Now, what do we put on the sign chart? Well, I put on the zeros first. What are the zeros of this rational? That's when the numerator is equal to 0, so it's going to be 2. It's a solid dot here, that's a 0. And then negative 7, solid dot, and that's a 0. And then I put on any asymptotes we might have. Where does that occur? X equals 0, that's right. So we put a 0 here. And I actually physically draw the asymptote, so I know that x can't be 0. And now I'm going to superimpose the numerator. What is the numerator? Its function. What shape is it? It's a parabola that opens up. And what are its zeros? Negative 7 and 2. So I'm actually going to physically superimpose my parabola through its zeros. Everybody follow that? And then the denominator is what shape? It's a line with a what kind of slope? Positive slope. So I'm going to superimpose that one through its 0. And so what are we physically doing with this parabola and this line? We're dividing them, aren't we? So if I were to divide a positive number by a negative number, what sign do I get? Negative, good. So this would be a negative number. If I were to divide two negative numbers, you get positive number. If you were to divide a negative and a positive, here we get negative and then a positive on the right. Now, you might say, well, I could just plug in numbers in each one of the intervals. Could you do that? Sure. Could you make a mistake, maybe? I am much faster at superimposing the numerator and the denominator and then doing the sign chart that way. All right, but I need to know when this function is less than or equal to 0. When is it less than or equal to 0? Yes, it's negative infinity to negative 7 with a bracket in union with parentheses 0 to 2 with a bracket. Because that's an asymptote, right? That's an open dot. Did you guys do this with Mr. Johnson? I hope so. Let's do another one.
So there's nothing in the,
I'm sorry?
there's nothing in the domain from them, so
Let's do it. There's nothing in the domain from negative 7 to 0. I am looking for when this expression here on the left-hand side is less than or equal to 0. I'm not talking about domain. Yes?
So for the that first positive, what did you like, the 2 lines did you fill out to?
This one right here,
Yes.
the blue one and the green one, they're both negative, aren't they?
Okay,
So a negative over a negative is going to be positive. Right, this is not domain. This is different than domain. I'm taking the pieces off of the graph that are positive and negative. Now, could we graph this? Well, we could. And I happen to have a driver. So click my Chrome and my apps, which are There we go, you got it.
Start graphing.
Highlight.
Oh.
And it's y, we'll do y equals, parentheses, what was it, x squared
Plus 5x.
plus 5x, I can remember what it's plus. Plus 5x minus 14, close parentheses, divided by x. All right, now, is this function indeed less than 0 when we are less than or equal to -7? And then, if you put in on line 2, please, x equals 0 as an asymptote. Make it dashed. Thank you, and then I'm going to do this so we can see it a little bit better. You see that?
So there's no horizontal options right now.
No, and we're going to talk about that later today. So basically, what a sign chart does, a sign chart shortens this process of you graphing it, doesn't it? And do you see how this function or this expression here is negative from, this is -7, negative infinity to 7, and then a union from 0 with an open parentheses to 2. Excuse me, and we got that just by superimposing the numerator and the denominator on, excuse me, the sign chart. All right, moving right along. Next one. Okay, number 2. Let's try this one. 3 over x minus 1 plus 2 over x is equal to 8. So right from the beginning, what do we know that x can't equal? 1 and 0. So x can't be 1 or 0. So if we get that in the end, we know it's extraneous. And now I need to find a common denominator, which will be x times x minus 1. So what do I have to multiply the first expression, this one by? X plus 2 times what? X minus 1 equals 8 times both of them, right? Oops, that's a minus. All right, now our denominators are equal, so what can we do? We can equate the numerators. So I can say then 3x, I'm going to simplify as I go here. 3x plus 2x minus 2 equals, that's going to be 8x squared minus 8x. And I'm going to move everything to the right-hand side because the square is positive over there. So this is going to be 0 equals, now on this side this is 5, so I'm going to subtract 5. So we get 8x squared minus 13x plus 2. You think that factor? No, that's just flat out messy. So this can be x equals 13 over 2a, which is 16, plus or minus the square root of 169 minus 4 times 8 times 2, all over 16. So that's going to be x equals 13 over 16 plus or minus. I happen to do that math already. That's 105 under the root. And those are certainly not equal to 0 and 1. So we're okay with those answers? So that's part A. That's the equality. You know where we're headed, right? Now we're going to do an inequality. And let's try greater than. So we'll say 3 over x minus 1 plus 2 over x is greater than 8. We're going to move the A over, yes. So this is going to be 3 over x minus 1 plus 2 over x minus 8 is greater than 0, yes. Finding common denominator. Do we already know what the numerator is going to be? What's it going to be? Because we already did the top work up here.
8x squared minus 18x equals 2.
Yeah. Well, if we move this over to the other side, though, it's going to be right. Because if we move the 8 over this way, let's do it all together. So this is going to be 3x plus 2 times x minus 1 minus 8x times x minus 1. I'll show you what I mean. So we get 5x minus 2 minus 8x squared minus, or plus, I'm sorry, 8x over x minus x minus 1 is greater than 0. You see how it's negative on this side? Plus 13x minus 2 over x times x minus 1 greater than 0. So we need to know when this expression on the left is greater than 0. So we're going to do A using a sign chart. Now I'm going to put the zeros of the numerator on my sign chart. Did we figure those out already? We did, didn't we? They're gross. Well, one of them is 13 over 16 minus the square root of 105 over 16. The other one is 13 over 16 plus the square root of 105 over 16. Now, I have no idea what those numbers are, but could I approximate? What's the number that we know the perfect square of that's close to 105? 100, okay, so the 100 would be 10 over 16, so 13, 16 minus 10 approximately over 16 is that bigger than 0? Yes, is it less than 1? So, okay, that's good. And then this one's going to be close to 23 over 16, which is bigger than 1, okay? So that's just kind of for our information, because now we're going to put the zeros on here. This is a 0 and this is a 0 of the denominator, which are 0 and 1. So I know this 0 is going to be on the left, and it's an open dot because it's an asymptote, isn't it?
This is more.
And then 1's just going to be somewhere in the middle here, so I'm going to just put 1 here. Now I chose this one, yes ma'am.
Would the zeros be open circles because we have a greater than sign here?
You know what? When I do a sign chart, I show that I'm crossing the x-axis there, and when I do my inequality, I see that it's a 0, so I don't include it.
Okay.
Does that make sense? The sign chart's actually what's going on with the, okay? I chose this one on purpose because do we know what a number is between 0 and 13 and 16 minus 1 of, I don't know, do I? Nor do I want to guess. So what we're going to do is superimpose the numerator through its zeros. What kind of shape is the numerator? It's a quadratic that opens down, so let's do that. That's easy enough to do through its two zeros. There it is. What about the denominator? What shape is it? That's just x squared minus x. It's a parabola that opens up, so if I superimpose it through its two zeros, which happen to go through the open dots there. Now, can I do some, what am I doing? I'm dividing them, aren't I? Those two values. So what happens when I divide on the left-hand side here, a positive by a negative? We get a negative. What happens when in the middle section here, I get a negative divided by a negative? Positive, negative, positive, and then negative. Now, my inequality states I want only the values that are bigger than 0. So let's read it off the sign chart here. Let's see. Where are we going to start? Well, I've got negative numbers here, so I'm not going to use those. So it's going to be 0, not inclusive, I'm sorry, comma, 13 over 16 minus root 105 over 16. Now that's going to be parentheses because it's greater than, in union with, parentheses, 1, good, comma, 13 over 16 plus root 105 over 16. It looks like a parentheses there, we can fix that. Is it really easy to superimpose the numerator over the denominator on a sign chart? It really is. Yes, ma'am.
Why do you have to use the constant over the inequality?
Because I like to use sign charts that are bigger than 0 and less than 0 so that I can, see which ones are positive and negative. And if I use 0 as my reference, then I can, clearly see. If 8 was my reference, it would be harder. You see how it would be done?
Get through it first, though, or do you like
No, you can find a common denominator and then move it over. Is that what you're asking?
Yeah.
Sure, you can do that. I just said it was 0.
Yeah. I was confused because I don't know if you had to do that.
No, you can do that at the end. And then, Questions on this so far? We're going to have our driver graph this for us. And no, I don't need to say. Okay.
Oops. Okay.
So we're going to help her, right, with the numerator. It was negative x squared, negative 8x squared, plus 13x minus 2, divided by x times x minus 1. And our asymptotes were at 0 and 1. Very nice. And we've got to turn 1 in here.
Do you want the top part?
So let's click on those points. Can we see what those zeros are? Actually, why don't we put points on this graph here? Let's put on line number 4. Let's open parentheses and go 13 over 16, minus square root, right, just like this. 105. I have the best driver on the planet today. 0. Okay, that's one of our points, isn't it? That's nice. And show the label. Good. And copy paste. Nice job. Okay, so let's look at our analysis here. I just want to show the red part of the graph down here. We wanted to know where this graph, right, on the left-hand side was bigger than 0. Well, it's between 0 and this 0, which is what we said, right? And it was from this asymptote to this 0. So it worked. Short of us having to draw that really complicated rational graph. Are you sold yet on sign charts? You guys are being polite. Oh, this is hard. All right, let's do another one. I'm going to go straight up for an inequality because I figure you guys can do the equalities. I need to put it in factored form already. What are we going to do? We're going to use a sign chart. Yep, we've got a 0 at 5. We do have an asymptote at -3. Good. Where else? 0. Good. I think sometimes that's the hardest part. Now what are we going to do? Superimpose? Let's do the denominator first, because I think that's easier. What shape is the denominator? Parabola, it opens up. Let's do that. It passes through its 2 zeros, which are the open dots because it's in the denominator. What's going on with the numerator? It bounces, doesn't it? So it's going to go, it's above everywhere except at 5. Do you agree? Mm-hmm. Now let's do our sign chart. What happens to the left of -3? Positive, negative, positive, positive. And we want the values where this expression is less than or equal to 0. So let's write that off the sign chart here. So where are we going to start? Good. -3 to 0, but I'm going to use parentheses. Good, because of the asymptotes. And using with just 5, yeah. And that's how we show the solo number, right?
Parentheses at the top.
I'm sorry?
How is it?
Less than or equal to 0? Am I wrong? I have to include this y, because what is the value here? It's 0 there. You got to include the 5. Tricky, right? How easy was that? It looked really scary, but was it really? So what is the key to doing sign chart? Number 1? Find the zeros, put them on your sign chart. Number 2, find the asymptotes where they will be. Put them on your sign chart. Superimpose the numerator, superimpose the denominator, and then subtract them. And see what kind of number you get. Is that easier than plugging in numbers in each interval? The answer is heck yeah. And are you less likely to make mistakes? I am definitely less likely to make mistakes. Okay, so shall we? Driver, take it away.
Should I hide all these?
Your fourth. Good. Divided by x times x plus 3, I think. And 0 is one of them, and negative 3. And our zeros for this is just 5.
Oh, sorry. Like,
All right, and so if I redo this, oops. Oops, I just really like doing a little bit of spreadsheet and it works, you know? The problem is that I think this one is down here somewhere. Where's it up here? Where's the other side of it? It's got to go down to 100 or something. 1,000?
it is right here somewhere. Oh, there it is.
You know, like, I have like from negative 10 to 10 and 1,000. Okay, so let's hit I'm going to cheat here, right? Okay, so on the x-axis, let's type in negative 10 to 10. And then on the y-axis, let's type in negative 1,500 to 1,500.
How'd you know that?
Well, because I did it before we got here. Okay, so, yeah, I'm a wizard, right? Okay, so we wanted to know when it was less than or equal, what was it, less than or equal to? And so it's only less than or equal to between these two asymptotes and at 5. 0. Pretty cool? Oop, I didn't even do that. All right, this is the challenger one. What number are we on? 4? What? Synthetic division, yeah, because we've got to find the zeros on the top. way to like get some review in, right? To do these over Q's.
Mhm.
All right, go Y's ones. What am I trying? 1?
Could you 7?
Well, that, we know 7 is gonna be an asymptote, we already know that, so. 1, that's right. Oh, there's a 2 here, so this is 2, that's -1, that's -1, that's 7, that's 7. No, right here. 2.
-1 works.
-1 works? Who's for negative? Yay, okay. Somebody else say something else there? Yay. So this is gonna factor. So what do we get so far? We get, x plus 1 times x minus 2 times 2x squared minus x minus 3. So this is gonna be x plus 1, x minus 2, 2x, and x, and 3, and 1 over here, and it's a -3 and a plus. Oh wow, it looks like I have x plus 1 quantity squared, x minus 2, and then 2x minus 3, all over, what? X minus 7, and I said I wanted the ones when it's greater than 0. So we're going to do our sign chart. So what are our zeros? -1. 3 halves. 2. And what is our asymptote? 7. Okay, I'm going to do the denominator first again, because it's what is that shape? It's a line with what kind of slope? So it's going to be superimposed through the all right, now, the numerator, what degree was that? It was a quartic, and it opens up because the leading coefficient is positive, and it bounces where? At -1. So it's going to be open up, bounce at -1, pass through at 3 halves, pass through again at 2, and then it's positive forever. Now I'm just making it positive forever so I can see it over on this side. All right, so let's do our sign chart. What do we get? A positive divided by a negative, 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 positive, negative, and positive. And I want to know when this is greater than 0. Non-inclusive. Oops, undo. Undo. So what do we get? 3 halves to 2, was open, right? Because it's non-inclusive. In union with 7 to infinity. Right, driver. Equal right. Now, was that difficult? Looked a little scary, but the zeros were reasonable to find. The second. 2x minus 3
Oh, sorry.
times x minus 2, yes. And then it was x minus 7 at the bottom. All right, and I'm sure we don't have to have our windows so large. Oh, sorry, we're just moving it this way. Or maybe we do. What?
Just hit the home button, it'll take you to a house, like a 10 by 10.
Oh. Wow, but boy, did it really zoom? Wait, I don't like that. See? Oh, yeah, I do, because it's positive, yes? I'm sorry. Just a minute. But in order for us to see the top part, it had to be at 600, didn't it?
Yeah.
I mean, let's make this y-axis up here like 800. 1,000. 800. 2,000. $6,000? Oh,
Hey.
wow, I did say 6,000, didn't I, before? And let's make it a negative one, like negative 1,000. So do you see that as positive? Well, we can't really see that as positive here, but we did for a minute, right, when we did the house zoom? All right, so that's all I have on inequalities and rationals, or do you have issues with any of that? Pretty simple stuff.
Can we stop it?
Mm-hmm.
If you have an extraneous solution, like, what would you do with that? You just not make it equal.
You would just say it's extraneous. Right.
Miss Molly, can we stop it? I can stop it up here.